Viscosity is a measure of a fluid's resistance to deformation. More commonly, we think of viscosity as the thickness of a liquid. The viscosity of a liquid is proportional to the strength of the intermolecular forces present, which is the connection we make between molecular structure to physical properties. In this demo, we're going to look at a series of three molecules: methanol, ethylene glycol, and glycerine. As you move down the series, you see that there is an increase in hydrogen bonding between the molecules and therefore an increase in intermolecular forces. As intermolecular forces increase, there is also an increase in viscosity. So we see a lowest viscosity of 0.56 centipoise for methanol, all the way up to 950 for glycerin. To demonstrate the differences in viscosity between these three molecules, we'll see how long it takes equal volumes of the liquids to flow fully out of three burettes. Going from left to right, we have methanol, then ethylene glycol in the middle, and glycerin on the far right. A little bit of green food dye has also been added to the burettes to make it easier to see. As the solutions start to drain, there's a steady stream of methanol and ethylene glycol leaving the burettes, while glycerin is only draining at a rate of about 1 drop every 2 or 3 seconds. As the top of the liquids in the burette begin to enter the frame, we see that indeed methanol is draining the most quickly, followed by ethylene glycol, and glycerin is barely draining at all. The differences in flow rate we see here are a bulk physical property, like viscosity, which reflect an underlying molecular structure component, like intermolecular forces. We can see that an increase in hydrogen bonding between molecules clearly is reflected in a bulk macroscopic property, like flow rate. As the ethylene glycol burette finishes draining, we notice that the levels of the glycerin have barely budged at all. Rather than filming this, we'll just note that it would take about 5 to 7 hours for this burette of glycerin to fully drain.